Hello everyone, my name is Ram and today I will be talking about
Have you ever pushed or pulled a wagon with something on it before? Or maybe moving furnitures in your house? Well, all of these are applications of combination of forces when there's someone helping you or when there is something that slows you down. So pushing and pulling, as we all know, is a force exerted on an object which causes it to move. However, what if when we push or pull an object, it doesn't move, or as I said before, it there's something that makes it faster or slower? Then most likely there is another force that acts upon the object. This is where the topic of combination of forces is applied. So what is really combination of forces? So Newton's first and second laws refer to net or resultant forces because there may be more than one force acting on an object at any one time. So this is the formula that we need to remember. Net force equals mass times acceleration. So basically, combination of forces is just like the sum of all the forces. And an object in equilibrium may have several forces acting on it, but the resultant is zero. So it remains at rest or maybe just moving at constant velocity. Objects with a net force of zero acting on them are said to be in equilibrium and have no acceleration. So as in this figure here, the there are two people that pushes the box in the middle with the same force, and they are pushing it. For example, the first man is pushing it here and the other man is pushing it the opposite side. Then if we sum it all up, 10 plus minus 10, because it's in the opposite direction, then it is equal to 0. That's why, so we can know that this box is in equilibrium. So what is exactly its resultant force? Well, it is the combined effect of any number of forces. So as we see here, for example, the first boy is pulling with a force of 70 newtons to the left, and the second boy is pushing with 19 newtons to the left. So the net force is just the sum. So 70 plus 90, since they are the two forces are in the same direction, then we just sum it up. It is equal to 160 to the left. So this is the net or resultant force. Now it's exercise time. So here I have an example problem. A cyclist and her bike have a combined mass of 80 kilograms. She exerts a driving force of 200 newtons and experiences an air resistance of 150 newtons. Find the acceleration of the cyclist. So first thing we must remember the equation before, which is net force equals mass times acceleration. We also know that net force is also can be called resultant force, and the resultant force is the combination of all forces. So it's essentially just sum of all forces. So first, to solve the problem, we need to find the given. Mass is 80 kilograms. Driving force is 200 newtons. Resistance force is negative 150. This is negative because it is going to the opposite direction. So that's why I put negative there. And we must, the unknown is acceleration, which is a. So this is the equation that I've come up with. So since net force is equal to sum of all forces, then I substitute that with Ft plus Fr, and it is equal to mass times acceleration, which is ma. So just substitute all values. 200 plus negative 150 equals 80a, equals 80a, then just sum the net force, it equals to 50. So we know that it is positive, so it is going to the right, plus 50 newtons. And since we're finding for acceleration, we must get the A here. So to get the A, we divide both sides by 80, and we will get 0.625 meters per second squared. That is the application of combination of forces.